To measure information processing, we used a FITS task to examine whether manipulating one hemisphere, in our case the left hemisphere, can affect the visual information processing. 3 females aged 16, 32 and 54 participated in this study. There were 2 parts to this task, one called no manipulation, in which the participants had both eyes open during the task. For the manipulation, however, participants were to cover one eye, the left eye for all participants, and complete the FITS task while the left eye was covered. This way, for the first task, both hemispheres were used in information processing, but then only one hemisphere, that is the left hemisphere, was involved to process the visual information. This experiment was video recorded. Regarding the FITS task, the target sheets varied in level of difficulty, which could mean that the amount of information processing varied in different parts of the task. In total, there were 6 conditions with different levels of difficulty. This research could help us to find out whether one's motor movement would decrease in speed as the tasks get more difficult, and if so, why? To do the task, the participants were asked to sit in front of a table in an upright position, with no part of their body touching the table. The target sheet was to be placed in front of participants so that the box labelled START was located in the bottom right-hand corner. Participants were told to hold the pencil with their right hand in an upright position so that the tip is within the START box. As soon as the experimenter says go, the participant was to tap between the circles as rapidly and as accurately as possible. Timing was to measure from the moment the participant hits the first circle to when the last circle was hit. In total, each participant was to complete 30 trials without the manipulation and 30 trials for the task with the manipulation, and these tasks were randomised. To control for left-handers, as they use their right hemisphere for information processing, we made sure all participants were right-handed. In this study, the predictor was the bits, and they ranged from 2 to 5, and the criterion was the times per target, which was the total time divided by 9, and then the average time per target divided by 5. Participant 1 with no manipulation on average had a slower reaction time for the times per target with no manipulation. However, participant 1 had a faster reaction time for times per target with the manipulation of covering the left eye and using the right arm for the motor task evaluated by the FITS task. From the results, the average time per target for participant 1 with no manipulation from 2 bits to 4 bits ranged from 469.2 milliseconds to 490.6 milliseconds, and at 5 bits had a large increase in time taken to complete the task at 617.5 milliseconds on average time per target. When comparing the individual results of the average times with manipulation, there was a gradual increase in time taken to complete the task with different levels of difficulty ranging from 2 bits to 5 bits. This is what would be expected when impairing her right hemisphere in the brain with the manipulation task. Participant 2's results were overall the fastest of the 3 participants. There was a slight increase in time taken for 2 bits to 5 bits, but there was no overall major difference where on average it ranged from 267 milliseconds to 375 milliseconds. This is quite unusual for the participant. When comparing to the manipulation of participant 2, there was a difference in results where for 5 bits with manipulation, it took 486 milliseconds of average time per target to complete it, and when compared to 5 bits with no manipulation, it took 375 milliseconds on average time per target. Participant 3's results were in line with what would be expected, given the increased difficulty of the FITS task measured by bits. From 2 bits to 5 bits with no manipulation, there is steady increase. For example, from 320 milliseconds average time per target at 2 bits to 617 milliseconds of average time per target for 5 bits. When compared to the manipulation task, results increased in the time taken to do the motor task with one eye covered. For example, 2.5 bits was 472.8 milliseconds for participant 3 with manipulation, and the time taken to do 5 bits with the manipulation was 753 milliseconds. We could possibly suggest that this participant, being the oldest, could have impaired vision in her right eye, which is impacting on her motor skills and/or her hand-eye coordination. Fitts' law applies to almost all aiming movements, such as using a computer mouse, putting bolts into holes, or even threading a needle. Our manipulation was to cover the left eye while performing the Fitts task. Results showed that doing this did indeed slow the participant down, which in turn had an effect on information processing. So why did this happen? Why did the participants slow down when they needed to move more accurately? There are 3 possible explanations for this. Firstly, feedback theory. This is based on the consequences of time that it takes to process visual information to guide a movement. The slower the movement, the more feedback will be available about the accuracy of the movement. Secondly, impulse variability theory. This theory states that there is inconsistency in the efferent system for movement of high force, which means the faster the movement, the less consistent the movement is. And thirdly, imagery planning. This theory says that the brain plans movements by forming an image of the movement, so if the target is slow, it will be harder to mentally see. Fitts' law can be because of any or all of the theories. So to summarise, visual feedback is to afference, impulse variability is to efference, and imaging is to central brain. Just a refresher on our participants. The ladies were all aged 16, 32 and 54 years old, and they were all right-handed. And by using the right hand to complete the task, the left hemisphere was responsible for the control over the right hand and the right eye. Experimental bias may have also influenced the results, as participants may have been trying to please us. Practice effect would have also had some bearing on the results, and although randomised, the more the participants did the task, the more they generally improved. Binocular summation is the phenomenon by which people see better with both eyes together than by either eye alone, called monocular vision. There is a 25% decrease in the size of the field of vision with monocular vision compared to binocular vision. Monocular vision causes a reduction in the peripheral field of vision and the loss of stereoscopic binocular vision. Monocular vision impairment refers to having no vision in one eye with adequate vision in the other. Accidents can happen when people with monocular vision impairment are in heavy traffic on the roads. This can be overcome if it is possible for them to be able to constantly move their heads from side to side to enable an increase in the visual field. People limited with one eye often have problems with depth perception as well. Judging distances can be quite difficult. eye-hand coordination, as well as mobility and orientation can be affected. Employment in areas most likely affected by monocular vision impairment will be those jobs that require close work, such as beauty therapists, machine operators, needlework, or surgeons. Also, vehicle operators, such as airline pilots, drivers of cars, trucks, or motorbikes, and any work that requires prolonged visual attention, such as computer users or even air traffic controllers. On a personal level, people report problems with employment, anxiety, and poor self-image. If the loss of an eye was sudden, there is an adjustment period for driving, walking, leisure activities, and work. Activities such as crossing a street, threading a needle, or climbing stairs may be challenging and require a lot more concentration. Precautions should be taken to protect the remaining eye from injury or loss. I am Jodie Best, and along with Tara and Rosa, we hope you enjoyed our presentation. Thank you.